Hello, all. Hello, John sir. Hello, Anupam. Am I
Hello.
audible?
Yes, you are on.
Yes, Anand, good evening.
Good evening, sir.
Okay.
Good evening, John sir, Anupam sir, Anand sir. How are you?
Good evening,
Good,
Navneet
madam.
ma'am
Good
ji.
evening. Good
Good
evening.
evening, Navneet. It is heartening to note that AI and humans both are attending the meeting together. A lot of AIs. Okay. So, John sir, can we start?
Yes, we can. Yes.
Okay. Thanks. Good evening, everyone. It is my pleasure to welcome you all to the first part of the faculty development program, which is a two-part program as part of AIORI 3. And AIORI 3 is, as you can see, is the third series which is happening. We started from 2024. We did it in 2025, which was AIORI 2, and now we are in 2026 doing the AIORI 3. The mission of this AIORI is to conduct an annual skill development workshops and hackathons to strengthen India's internet infrastructure resilience and build a self-reliant supply chain of technical talent, limiting the country's exposure to externalities. This has been very carefully drafted to ensure that our objective remains clear at all times, wherein we absolutely are sure that there is no dearth of technical talent in the country, but there has to be a continuous development program, continuous program of feeding with the latest information and tools and techniques so that the supply chain for this technical talent is ensured. Now, just to make you aware, I'll just quickly share my screen to take you through some of the key things which has happened over last 2 years, and then I'll request John sir to give the welcome address, and then Anand will specify the learning objectives of this program. So to do that, I will just quickly take the share of the share my screen. Okay. So AIORI 1 was which happened in 2024. Therein we had 5 workshops. We did a hackathon where we participated with 23 teams, and then 5 finalist teams received their certificates, out of which we uh, took 2 teams to the IETF hackathon, which happened in Bangkok. So overall, there were more than 250 participants in terms of faculties and students. And then we had more than 69 people working on the problem statement. So this is what happened in AORI 1, wherein the primary focus was to work on internet related internet standards and drafts. Then in 2025, we changed ourselves a little bit. We moved on, and instead of doing a student workshops, we first did a faculty development workshop. The details are on this page. As you can see, we did this faculty development workshops at 11 locations with 293 faculties participating. And then one day student workshop was organized across India where more than 1,500 students participated. And some of the faculties who did this and made this possible also are here today with us. And then we had a remote hackathon and followed by a physical hackathon. Again, if you want to look at what the teams did, their codes, their GitHub repositories, everything is available on this particular page. Now, moving on from there, we wanted to have AIORI 3 in a different format, little change based on what we have been able to achieve and what we want to do the course correction. So there was an expression of interest form which was floated for doing the workshops at your end. To enable that you are able to do the workshops at your end, this is the faculty development program which is happening today. As part of this, you will see what is being taught today. So this is the page where things are there. The details, pre-reading materials have also been shared with you, and lot more information will be coming to you throughout the workshop today. And now I'll request Arnab to share his slide deck once again. Thanks, Arnab. Let us move to the next slide. So this is where we are in terms of the inaugural session. I have set the context, and now I will request Professor John George to give the welcome address. Over to you, John, sir.
Good evening, all of you. Thank you, AIORI team, Anupam, Anand, and their backend team from AIORI for organizing this program. From the Information Security, Education and Awareness, which is the flagship project of Ministry of Electronics and IT, Government of India, which is collaborating this event at national level. First of all, I congratulate all the participants who have shown interest in this program. So this is like 3 to 4 months of an activity where your involvement will be checked. But then to begin with, some of you may be familiar with the topics of internet standards, governance, internet operations. Some of them may have an interest to learn. So as what Anupam already mentioned, we will have an initial 2 weeks of time where you will learn about the things. The study materials are there. The resource persons would be going through this material, will be walking through the material. So these Wednesdays and Fridays are being then identified. If by chance you wish to attend the program once again, please do attend on Friday. Please go through the study materials so that you can get it clarified. So by end of July, we expect all of you to be comfortable in delivering such kind of a similar session, which is planned for the workshop, which can be scheduled anytime from August 1 up to September 15. So there are some of the participants, there are more than one participant attending from the college. We always welcome such kind of an enthusiasm. By the end of this month, we will converge on who would be the point of contact. And then the others can assist them. And we look forward for the college with the maximum number of participation as well. So to faculty members who have a passion in this domain, please do go through the materials a priori, interact with the resource persons, build up your background so that we can use it for the next level as the resource person in the subsequent edition. Faculty members who are willing to learn and coming up, then we really appreciate your goodwill. I'm sure that these sessions will help you. All the support would be given from AIORI team. We require a resilient internet, a reliable internet that is there in our country. And that has to happen from if we are sensitizing our students. Many a times, these topics are not part of the curriculum. And you know, even in universities or AICT approved colleges, it takes a lot of time to get the curriculum revision. But in state-of-art topics or problems that are of very much need of for the growth of our country, we have to take initiative. Being faculties from IIT, we will put up the lead along with AIORI, and then you all have to be the flag bearers. So they will walk you. It is not like they completely teach you from the basic. There is no need to teach a teacher. They will rather do the facilitation process. The materials are available. Have a passion, a curiosity to learn, such that at the end of 3 to 4 months, we can tell that we have a larger group so that we can present our report to the ministry, including the colleges that are participated, so that the ministry also may look for a larger kind of project with a bigger budget in the subsequent years where we all can be stakeholders. All we look forward is an enthusiasm from all of you. Stay connected. Some topics may be totally new and difficult, but then in the world of the internet, all materials are available for you to clarify your queries. We expect you to get a mastery of these topics by the end of July, such that you are good enough. The subsequent guidelines would be shared by Anand and Anupam. Wishing all the faculty members a wonderful learning atmosphere. So we look forward for a large pool of people interested in computing systems and internet by the end of 2026. Once again, congratulating and thanking you. I know evening schedule may be a bit hectic for those who have to take care of your family, children's homework, cooking and all. But then all we ask is only 2 days, one in this week and one in next week. So if by any chance you are not able to completely attend it fully, please do attend the Friday program. And please don't miss the next week class. So with 2 weeks, sessions would be over. Okay, so with that, I wish all the participants the very best. We will be interacting you in the subsequent weeks. Some of us would be visiting your colleges down the line as the situation permits. But then we look forward for a greater team building. Thank you.
Thank you, Professor John Joss, for a lovely welcome address. Now I'll invite Anand to talk about the learning objectives of this program.
Yeah, thanks, Anupam. Thanks, John sir, for setting the context and the welcome address. And hello, everybody. And I'm really grateful that all of you have shown that interest in this initiative. Whenever we are talking about this workshop and hackathons, this is something which is whenever we have gone from year one, year two, and year three. In the back, there is a research project, understanding the nuances of internet, how internet works, measure it, evolve it. Whenever we see internet, it has been developed, it has been kind of uh, invented in US and European countries. We have been users to this. Whenever we have tried to understand what is the problem statements of internet in India, and across this region, we have seen that there are a couple of things which are missing, and we have, as a community, worked for, and we have developed a measurement ecosystem backed by a standards development platform, which is the base of these all initiatives. The idea over here is to bring this platform to the academic and research institutions, the people who are interested, give them the tools, give them the data repository, give them the idea, and give them the problem statements which can be used to strengthen the internet ecosystem and the technology aspect of India. We are talking about operations, engineering, measurement, all aspects. Idea over here, the learning objective will be we all will come together, the students and faculty, and will try to learn, try to measure, analyze the data, and build ecosystems, build products which can be standardized. And there is a platform available to deploy that particular standardized product, and then we can contribute in the global standard making process, and which is actually fueling the internet ecosystem across the world. This will actually help you to understand internet measurements, fire measurements. This workshop, whenever you will, the team members will walk you through different aspects of internet, how it has grown, what is the platform all about, and how you can enroll yourself and how you will come together. I will not take much of your time because there are lots to learn over here. This is an ongoing process. I'll just give you an example that all those who have been kind of graduated in the first and the second year still are kind of contributing as interns and employees with us, and also as other capacities across the world. So it is something which is we are trying to make a sustainable contribution from you, and we wish to have a sustainable contribution from all of you. So the learning objectives over here will be more contribution towards internet standards, measuring the nuances of internet, and come up with data-based understanding of what is the problem statements, and if we can work on optimizing and troubleshooting the internet ecosystem and build and evolve internet ecosystem in India. I'll just stop over here. Over to you, Anupam. Thanks everybody for showing your interest in this initiative.
Thank you, Anand. Let me introduce you to my team today, the resource persons who will be taking you forward. Both me and Anand will be there continuously, but the bulk of the load will be driven by our star resource person, Arnav Das. He will be assisted by Aditya, Debarga, and at times Devayan as well. He is there. Srijit, you can see, is managing the entire uh, hosting arrangements. So in case there are questions, you are raising hands, he will do the logistics part from there. And finally, we also have Andrew Mukherjee, who will be taking you through the last part of the session. So with this, over to you, Arnav.
Thank you for the introduction, sir, and thank you everyone for joining this FDP session. I'll start with the history of the internet because when we are studying about the internet, it really helps knowing how internet came to be, and this gigantic network that we see nowadays is how it started in the initial days, right? So in 1960s, World War II ended 2 decades ago, almost, and everyone was aware that that information was the next big thing, and people need to share information as fast as possible to uh, to win wars and just to come out on the top. So US and its military organization, that is the military research organization, that is DARPA, started discussing a concept for universal network for sharing the computer resources that they had. Also, at the same time as the telephonic network was pretty well built by that time, people started discussing packet switching, which was initially inspired from the circuit switching that was already there in the telephonic networks. So by the end of 1960s and in 1969, ARPA, a subsidiary of DARPA that was researching in this internet network, started creating and deploying these networks over their different institutes. Some of them were UCLA, UCSB, University of Utah, and Stanford Research Institute. So this was basically the early internet experiments that they were trying, and this is what made internet today. Following years, Vint Cerf and Bob Kahn published their research in something called Internet Experiment Notes, where they published the first drafts of TCP/IP that we read today. TCP/IP is basically the most important protocol on top, one of the most important protocol on top of which, or protocol stack on top of which the entire internet runs today. So as the network was growing, Stanford Research Institute started storing the names with the IP addresses for each and every system, and they started storing them in hosts.txt, a file that they had in their server. And as the network grew, it became more and more important to have a central file where all these IP addresses were mapped to the domain names or host names. So this host.txt became really famous, and they started sharing them within each other. And in 1980s, DNS, the initial version of DNS was established when John Postel, who was maintaining the copies of these host name to IP address mapping, asked Paul McApatrice to find a way to make this DNS sustainable, make this host.txt sustainable. Before, host.txt was like a phone book to the internet, where there was some name and there was some number, there was some host name and there was some IP address. Now, as the network were growing, it was becoming too thick of a phone book, and it was getting harder and harder to track which IP maps to which host. So in 1983, Paul McApatrice came up with DNS. Now, even today, the entire internet works on same principles. There are the names, that is the domain names, and the numbers, the IP addresses. So these are some of the examples of what the names are, what the domains can be, and what the IP addresses can be. But this is the numbers part are not just limited to this. For the numbers, it is not just IP addresses. There is also some particular numbers that are reserved for different purposes, like for TCP, like UDP. For TCP, we use the number 6. For UDP, we use the number 12. Now, these are the numbers that are not visibly present every time, but these are used internally in each and every packet that are shared between the systems. We all know how a local network is usually set up in a controlled environment. Usually there are different systems connected to a router, and one system can send some data through something called an IP packet. So if there is 3 computers set up with 3 distinct IP addresses, if we want to communicate between PC1 and PC3, we can send the data with adding an IP header and adding source and destination IP addresses. Right. Now, this works in a very controlled environment, but when we are talking about internet, this becomes really hard to maintain. It is not possible for each and every system to connect to a single router. So what usually is done is there are multiple local networks that are created and they are connected with each other, and these routers that are connected to each others starts sharing the routes that they have through a protocol called BGP. So BGP is one of the core protocol that creates the internet. Internet, as the name suggests, it is interconnected networks. So networks, we all set up networks in our home, in our labs. The interconnection of these networks is what creates the internet. And interconnection of these networks means exchanging IP routes. And this exchange is done through a protocol called BGP. Now the routes are exchanged properly, one can connect from one system to another. But then again, the IP address, we don't always remember the IP addresses. Nowadays, we never remember the IP addresses, right? So if we have to open something like example.com, we in the browser will write example.com and it will magically open. We don't have to remember the IP address. Even though the routes are shared, we are connected to some network, which is connected to some network, which is connected to probably the network for example.com. And we probably can connect it with an IP address. We still use the domain names because that is more human, right? So there needs to be some system that manages this example.com's mapping to the IP addresses. And that is the DNS, as we discussed a bit ago. So the DNS works in a way where we ask a DNS server, a completely different system, for an example 8.8.8.8, that, hello server, tell me where is example.com? What is the IP address of example.com? This new server 8.8.8.8 will do some magic and provide you with an IP address which has the content for example.com. This is the server where example.com is hosted. And this is done for each and every resource that we use in the internet. Each and every website we open, there are tens of DNS resolutions happening, tens of domain names that are being resolved before we connect to the main server. The magic that 8.8.8.8 does is something called a recursion, and 8.8.8.8 is basically an example of a recursive DNS resolver. 8.8.8.8 asks 13 constant root servers that are already there. We all know the IP addresses. These are well-known and well-registered root servers, DNS servers that maps the entire that acts as a starting point for the entire DNS. So if we suppose we want to open wikipedia.org, what a recursive resolver will do is it will ask the root server first for the address of org, the TLD. Once it gets the IP address for org, it will go to org web servers and DNS servers, and it will ask where is wikipedia.org. Once it gets the IP address for the name server for the wikipedia.org, it will go to wikipedia.org and it will ask give me your main HTTP servers or web servers IP address. This entire recursion is done every time, almost every time you open some resource in your web browsers. Now there is caching that is usually done in order to make this recursion faster, to make it less dependent on the servers every time. So every time you ask 8.8.8.8, it will probably not follow this chain. It will just try to reply from the cache that it maintains. But if the result is not in cache, it will traverse the entire chain, and then only you get the IP address of wikipedia.org. And this is done for each and every web request that we do. And probably for each and every web request that we do, internally, there may be many more dependencies like this. So any single web request that we send, it may be that there are 10 web requests behind it that is running. So every time we do something, there is some DNS server that gets hit. So how to make this more optimized? What we do nowadays is every time we try to connect to some server, say cloudflare.org, we have to traverse through a lot of different intermediary networks before we reach cloudflare.com. Instead of doing that, modern networks can be configured in such a way that not just the DNS cache, but the entire website's cache can be accessed from directly the ISP. This is something we call the edge computing. We store the cache directly at the edge locations. This can be your ISP, this can be your nearest data center, this can be anything that has a cache near you. And usually these are routed through an IXP, which again connects multiple ISPs, but there are different ways to achieve these basically. So nowadays what we do is we cache everything in a server that is near to us and share the content from there. So every time there is a match going on that we see in our phones or in our laptops, most of the time and almost all of the time, the content is served from a cache server and not the original server. So the original server sends the data to the cache servers, and we at the edge location, we as end users get the content from the edge servers. Now, if we have to maintain this, we need to know about the infrastructure, because this routing and this network needs a lot of infrastructure to work, right? So this is what the internet kind of looks like. These are the submarine cables that connects different countries with each other, different networks with each other. So anytime a packet goes from India to, let's say, US or Singapore or somewhere in Europe or in Australia, it travels from one of these submarine cables. These submarine cables are the backbone of the current internet that we use. And so this submarine cable facilitates IP routing and BGP routing. But IP is not the only thing on which we depend daily, right? There is also DNS. So the 13 root servers that I just talked about, the 13 root servers are also distributed all over the world. The 13 root servers, the location that they are hosted, every location that is shown in this map has some cache of the root servers, of the 13 root servers. In India, we have around 100 different cache of different root servers. Most of the original root servers are with US, and they have a monopoly in a lot of factors in the internet, along with the root servers as well. So these root servers are where the entire DNS resolution starts from. This again has a similar concept of the edge computing, but so all these servers are announcing the same IP address from any cast, and the idea behind so many cache servers distributed over the planet is that whenever I need to do a DNS query, whenever we do a query to a root server, the packet should go to the theoretically it should go to the nearest root server that is available to me. If that happens all the time or not is a complete different issue, and it is still something that is studied, still something that people are trying to solve. This is still something that people are trying to optimize. Now, when we talk about so much, and when we are talking about so much infrastructure, we also need to talk about security. And why specifically we need to talk about security and we need to focus on security is because when these protocols were being built, security was not the first thing that came to the mind of the developers. They were trying to solve a different problem. They were trying to solve the problem of information sharing, resource sharing. They were trying to solve the problem of connectivity, right? So TCP/IP, DNS, all these protocols do their work really well, but these were not built inherently to be secure. Right? Nowadays, we have implemented a lot of different security protocols like TLS, like SSL. Almost all the websites we open nowadays are SSL signed. All of them use TLS 1.3. All of them are using some form of security while serving the content. But most of the security protocols that are adopted and are well adopted, most of them are in the application layer. There is a lot of security that is needed to be implemented. There is a lot of security protocols that are needed to be implemented in the routing layer, in the DNS layer, as I was discussing for about the IP address, BGP, and DNS servers. There is a lot of ways that there are a lot of things that we need to do in terms of security there. There are existing standards like RPKI, DNSSEC, and others, IPsec. These are well-studied protocols. These are well-studied standards. The only problem is the awareness and the adoption. DNSSEC is still lot adopted in a lot of places. All the root servers have DNSSEC. Almost all the TLDs have DNSSEC, but when it comes to the original domains like say example.com or wikipedia.org, I mean, these are big organizations, so they probably have a DNSSEC enabled, but there are a lot of domains that do not have DNSSEC enabled. When we do not have things like DNSSEC, what happens is domain or DNS hijacking. Same with the RPK, same with the routing, same with BGP. So BGP also needs to be secured. BGP works in the backbone of the routing. So if BGP is not secured properly, if the routing is not secured properly, we won't be able to access the internet. And that is done through a protocol called RPKI. At least RPKI is one of the standards through which BGP is secured. But RPKI's adoption is also very limited, although it is well studied, it has been there for a while, but the adoption of RPKI is still very limited. And these are the spaces that are actively being researched on. These are the spaces where people are actively debating how this can be optimized, how these can be adopted. And that brings us to the governance of this. The governance of the entire internet infrastructure that we just saw depends, not depends, it is managed through by a few organizations like ICANN, like IETF, like IANA, and all of these organizations have different uh, spaces that they work on. For an example, ICANN works more with the policies, IETF works more with the engineering perspective, and IANA works mostly like a registry. All three of them comes under Internet Society, which continuously funds them to maintain the internet that as we see today. IETF has a lot of different organizations contributing to it, and IETF always try to have as much consensus as they can for every protocol that they build, every standard that they build. ICANN, on the other hand, works on a multi-stakeholder model. And the people who are like proposing the policies here, the people who are trying to build the standards, the protocols, the people who are discovering the issues with the current internet infrastructure, they come from they don't primarily work for ICANN, or they do not primarily work for ITF. They come from different organizations like Cisco, Google, Apple, Ericsson, Nokia. These are people who are educators. These are people who are working with networks on a daily basis. These are people who have worked with networks and are facing some issues that they are trying to solve. IETF, ICANN, both of them have their yearly meetings, and all of these meetings, even if not all, for ICANN, most of the meetings, and for IETF, almost all the meetings are very well documented so that each and every protocol, when they are built, when they are discussed, each and every flaw when they are discussed, everyone in the planet can just go to their website and they can read what people are discussing, what problems people are facing, why people are not adopting something, what are the methods someone is solving some issues. So IETF majorly works on the engineering perspective, whereas I can work majorly on the policies. IANA, on the other hand, works mostly like a registry where they maintain the standards and constants like the root hints, the zones, the trust anchor, TLD, and this is for the DNS. It also IANA also maintains the numbers for the protocols, and it also maintains the allocation for IP addresses. So this is an example. This in the screen you can show that there are some protocols and their uh, numbers that have been assigned by IANA and are maintained by IANA. This is open. This can be found in IANA's website. So here you can see UDP protocol has a number 17 allocated to it. IPv4 has a number 4 allocated to it. There is TCP has a number 6 allocated to it. So these are the numbers that works internally that are not always visible, but each and every packet has these numbers, and this is how you can decide a packet is an IPv4 packet, the IPv4 packet is a TCP or a UDP packet, what kind of TCP packet it is, what kind of UDP packet it is, and all these things are very well defined in both RFCs and IANAs and IANA's registry. Following this, the IP addresses that are used to communicate with each other that we use, and each and every organization has some kind of IP address for us to reach that organization, right? Each and every website has some IP address behind it. Each and every system nowadays has an IP address behind it. So that allocation is also somewhat maintained by IANA. IANA maintains the RIRs or regional internet registries, and this regional internet registry maintains the IP address allocation under them. There are 5 regional internet registry RIRs: Afrinic, APNIC, ARIN, LACNIC, and RIPE MCC. We primarily depend on APNIC because APNIC is APNIC maintains the IP allocation for Asia Pacific region. So each and every IP addresses that is maintained in India or generally in Asia Pacific region, in some form, in some sense, is coming from APNIC. It may not directly be coming from APNIC because even these RIRs have national internet registries under them because APNIC has to manage a lot of countries. So APNIC cannot provide IP addresses to everyone. So in case of India, we can get an IP address allocated to our organization, to any organization through the National Internet Exchange of India, NIXI. In case of Japan, I think it is JPNIC. In case of China, it is CNNIC, and so on. So different countries have different organizations under APNIC or under any of the regional internet registries who manage the allocation of IP addresses. Under these national internet registries, there can be more internet registries like some local internet registry, there can be some ISPs, and at the end, we as an end user get the IP addresses allocated to us. Whenever we are allocated some IP address, then the information for that travels back to the ISP, to the National Internet Registry, to the RIRs, and they all maintain a big log for who is maintaining what IP address is allocated to which organization. Going forward to what IIRI does, what we do, we work primarily on internet infrastructure research, and we work on measurement and analysis. Now, these are the two things that one can do with the internet. One can either measure and analysis the existing internet, as I just discussed the BGP and the DNS systems on which we depend every day. There is routing, there is sharing of the internet routes. Are these things working as they should, as the RFCs intended them to be used as? So that thing is measured daily. That thing is something that is to be analyzed, and people do analyze them at a pretty frequent basis. On top of that, once there is some analysis, once we know that some protocol is probably not used properly, or some routing is not done properly, what we can do is we can do research on how we can fix that. So there comes the internet infrastructure research. This can span between creating a protocol or adding some additional extensions to a protocol. It can be like adding some security extensions, or it can be like saying that, okay, you are using this protocol, but these are the best practices that you should use for the protocol. So that is how DNSSEC came to existence. That is how RPKI came to existence. Moving forward, the internet infrastructure research that we do. Some of the research that we do is we do resilient DNS. We are trying to make the DNS implementation more resilient. This is a problem statement for every country. Every country is trying to make their internet resilience more resilient, and we in IIRI we are trying to focus particularly on DNS to make it more resilient. Also, there is buzzword that is coming a lot nowadays is quantum, right? And quantum threats. Quantum is uh, eating up all the encryption. Nothing is safe anymore. RSA is being broken, right? So post-quantum cryptography is a standard that everyone is adopting very fast. IETF, in each and every IETF meetings, people are always talking about post-quantum cryptography and how they are implementing PQC in some software or another. So each and every software that we depend on daily, that maybe the DNS servers, that maybe the web servers, that maybe routing. I'm not sure how much uh, routing infrastructure is the cryptography scheme in the routing infrastructures are changed to PQC, but there were some discussions regarding it. So people are trying to adopt post-quantum cryptography a lot, and we are also trying to implement some of the standards to existing softwares like the DNS infrastructure and the hierarchy. Also, we are trying to work on finding more accurate geolocations for IP addresses. These are some of the works that we do. We work on a lot more things, but these are some of the things that directly maps to the work that is being presented here or the topics that are being presented here. In measurement and analysis, an example of measurement and analysis uh, portal is RIPE NCC. It is one of the most famous ones that is being used, that is deployed worldwide. RIPE NCC is also one of the RIRs under IANA, and how they work is they have these uh, small devices that they have uh, implemented and they have uh, distributed all over the world. And from RIPE NCC's website, we can fire different kind of measurements from all over the world through these small devices. Now, when we talk about measurements, what we mean by measurements, it can mean anything from a simple ping command to a trace route, like tracing the route from which my packets are going from one place to another. All the network between me and, let's say, wikipedia.org. If I want to open wikipedia.org, there needs to be some method for us to determine that this is the path that my packet took, and that is trace route. It can be something, so the measurements can be like ping, it can be something like trace route, it can be something like DNS measurements, like how fast is DNS resolution working in some networks, or which root server instance is my server connecting to, or my client is querying to. All these measurement information is necessary for us to understand how the internet infrastructure is working, if the standards that are already built like BGP and RPKI, if they are properly working or not. RIPE NCC has a lot of different anchors or anchor points distributed all over the world. We are in IIRI project, we have also built our own measurement network and we have deployed all over the country. So IIRI anchors, IIRI measurement nodes are not deployed all over the world, but it is deployed all over the country. Anyone who registers in the IIRI portal can just open our website and try to run some measurements. Whereas in case of RIPE NCC, the way they operate is to fire some measurement. We need to either go into some of their, we have to look for some of the presentations, or we have to follow some of their workshops, and only then we can get the credits that we need to fire the measurements. In case of IIRI, it is a bit more open, and it gives a little bit more freedom for people to fire measurements. So for IIRI, we have different nodes and different anchors deployed all over the country, and we can measure the latency of different resources from different parts of the country directly from our portal. That is the idea behind the measurement and analysis. Also, what we can do is what we do usually is we every day measure the latency of different root servers that we are discussing. So it may be that some root servers are working slow compared to other root servers. It may be that some root servers are not getting a lot of traffic in some area. It may be that at certain time of the year, some root servers get a lot of traffic and they slows down. So these kind of things can be measured if we do measurement daily, or or we do it in frequently at least. So this is also something that we do. This entire data is available in our website at iori.in. I'll move the mic to Oindri to further explain what can to further explain about the things that we do in IORI.
Thanks, Arnav. So by now, I can expect that we have gained valuable insights on how internet functions. Okay, so it's time to shift our focus on how we measure with AIORI portal. Okay, share the screen. As Arnav mentioned, that in our IRI, how we are measuring internet. Basically, this is our anchor network. Okay, so throughout India, these are the places you can see where our anchors are deployed. So looking at the metrics, you can see we can tell that over 300 plus anchors are deployed throughout India. Currently in North, around 27 anchors are deployed, in South 60, East region 56, and West 12. Okay, so this is the deployment metrics that region wise that we can see through our the anchor network that is totally deployed in throughout India. Secondly, what are anchors and how we are measuring it? Basically, let me just give an overview of that. So, the anchors are basically Raspberry Pi devices. Okay. So, for turning this anchor on, what we need an internet connection and a power adapter. Okay. Jumping onto like I'm just going through the steps for so this is basically a anchor. In this box you can find a Raspberry Pi device where internet connection is there. We provide internet connection and power supply to it, and this is how in these places this physical devices are deployed. Okay. Now coming to how they are getting registered in our portal. So we have a portal, our measurement portal, that is v2.aiori.in. So if you register over here, then you can find there is a section that in anchor management, anchor registration is there. What we do, why we provide the anchors who are taking it on lease, we provide them with a QR code. that person registers the QR code in our portal, enters the location, and this is how the anchor is getting registered to that particular location. Suppose for me, the IN26 is already registered. So if now I shift to some other location, I can update the location, and that is how it works. So basically, to if you want to run some comments, like now how we are using it for the measurement purpose. Basically, this is our anchor network, you can see. So basically, if we click on to some anchors through our portal, then we are asking that particular device to run a command for us, okay, from that particular location. So suppose, as Arnav mentioned, I want to run a ping. Then I will ask this IN45, please run a command ping for a particular website, suppose google.com, okay, or a DNS query or a trace route. This, and it will run, and like it will get back the response to us. We'll get back the response. Okay, that is how we are measuring internet through different locations. So this is our anchor measurement network, and we are currently measuring our several. Just let me show you one thing. So basically, there are 10 nodes we have currently. Okay, so we have 10 nodes all over India. You can, if you tap onto this, you can see we have one node in Chandigarh University, Pune Institute of Engineering and Technology, DY Patil University, IISc Bangalore, Sri Sri University. Then we have IIT Guwahati. If we click onto this, we have in Basis Technologies, then Shibpur, Indian Institute of Engineering, Science and Technology, then IEM Kolkata. Now, suppose I am taking as an example DY Patil University. So how we are doing it? Basically, with our anchors, we are running a regular ping through these node endpoints to measure the latency. And that is how we can get how each ISP is behaving. Like if I click on this Kolkata anchor, I can see the behavior of the internet, how it works, what is the latency we are getting through it. Okay, so for this, I can see for DY Patil's node, we are getting 158. Okay, that is the max latency that we are getting now. On average, 92.13. This is how we can compare the performance metrics. Okay. So basically, we are taking here each unique ISPs, and here through our deployed anchors, we are measuring and comparing the results. Okay. So this is one thing that we are doing. Second is, suppose, let me run a latency test. Suppose I am running it for google.com. Let's see. So basically, what know your latency means? Know your latency means using our deployed anchors, we are testing the connectivity. Okay. So from different locations in India, we are just targeting a specific website. Like I have targeted google.com, and then I'm checking what is the latency coming. You can see that from Chandigarh, this is which is connected to Tata Teleservices ISP, we are getting RTT average of 30.93. Okay, from Coimbatore, 47.616, Gotapatna, 55.97, Greater Noida 29.05, and this goes. Okay. Here you can filter, like if I check, okay, it got refreshed. So if I check 31 to 50, that is 31 to 50. Two places are there. Okay, one is in Jaipur and another one New Delhi, Faridabad, that region. Less than 30? No. So basically, this is how we can check for each region what is the performance. Means what is the latency that is coming out. So from above 70, there are two for google.com. Let me see. 75.78. Okay. On this Nagaland area, and 55.24, that is the average one, but it's coming as 70 as RTT max is 71.194. This is the maximum around West Bengal region. So this is how we are measuring the internet. We are measuring the ping. And okay, so now let me just give you a walkthrough our AIORI tools that we have. This is the check your website latency. So suppose you can give your college name and test if it is pingable, your website domain is pingable, then you can get results. Suppose another website I am checking, it's checking for stackoverflow.com. Yes. So for stackoverflow.com, Bhopal, Gothapatna, Haldia, Kutaband, these are the places where the latency came up. That is 46, 40, 14, and 47. Next, coming on to our measurement portal, that is v2.aiori.in. On session 2, we will be covering these things because there we will be running some practical measurements. Okay. I will be guiding how you can enroll students, how you can give an assignment, then how can ask the students for firing some measurements through our portal for some specific website, or and with our deployed anchors, creating some zones, northern, southern, western zones. Okay, so I will just give you a walkthrough on it and conduct
May I
some.
interrupt, Andre? May I interrupt, please?
Yes, sure.
So, once we have taken all these measurements, we have measured the latency. Now, what we do of it? What's the next step?
Yes, we can do analyses. Okay, based on the outputs, based on the measurement data, we can use for research purpose. Okay, and we can figure out the how it is behaving. If we run a periodic measurement, then we can analyze that how it is behaving in the morning and how it is behaving, that particular website is behaving in the evening or at night. Okay, so basically we can use the data for our research purpose.
Also, for measurements like trace route, we can detect if there are routing detours that are happening. With the DNS measurement, we can measure if some particular root server and in some particular location is giving more latency, is taking more time to return the data. Okay, so these kind of things can be measured because
So, in future, can this data, apart from using it for research, can it be used for internet, building of internet in India? Like, can we use it for the nation building or something like that? The raising up the internet infrastructure of India, our own infrastructure?
Absolutely.
Absolutely. So,
Absolutely.
so the routing and BGP is already drafted in RFCs, and they are working internally, but we don't know what are the how it is configured, what are the preferences that it is taking in for each and every network, right? So it may be that in some area the networks in some network probably there are things are not configured probably, and that is why in that area the internet is slow because there are a lot of routing detours. uh, Probably it is not taking the shortest path or the most optimized path
So
probably.
are we
Yeah.
giving these inputs to the ISPs or to the people concerned so that appropriate measures could be taken to correct it?
So that is the idea of the entire portal. So for now, the portal is working as a um, as something that collects the data uh, actively. So each and every, like, we need to fire the measurements. We have to first create an experiment and then fire a measurement for that particular experiment. If we can plan that we are trying to measure this, and then we start firing the measurements. Now, once we get the measurement, we can do analysis and we can ask uh, the network operators or the ISPs that this
So
is the
ultimately,
benchmark. Yeah.
this is the whole purpose. Like, we are starting slow and finally we'll come up to this.
Yes, it
That's
is one
the,
of the purpose. So
yeah, okay.
not just so it's not just about talking to the ISPs or the network operators, but it is also about understanding how the internet is working in a particular region or is working in general. Okay, so whenever we are opening some website, we are facing some latency. It may open fast, it may open slow. We can capture the latency, but that is all that we are limited to in general. Even if we are a bit technically sound, we can run trace route from our own system, but we don't know how, we don't know what will happen if I run trace route from 5 different locations. So with that kind of information, we can try to understand how the internet is actually working underneath, and we can also try to like
We can
propose some
also approach,
ideas
yeah. We can,
in,
yeah.
yeah, to
We can
IETF. We
also
can
approach to
probably
them. Yeah.
discuss this in
So,
IETF that
Yeah, Nab,
this is a problem.
this is
Yes,
Anupam.
sir.
So, if I can summarize what you and Andre are together trying to say, and thank you for your question. So, uh, this indeed is an initiative which provides us at some level a macro insight into how our internet infrastructure is working or it is behaving. And that paves the path for how it is going to be evolved. So when you say that whether it can be used for nation building or not, absolutely. The macroscopic insights which we get by these measurements, it allows us to curate our internet infrastructure to that standpoint. On top of that, what Arnav started by saying was that we can use the data for analysis, and then there is this is the first ever platform which has come up from within India to ensure that the data which is getting generated is acquired by an indigenous platform. It is shared within the Indian community, and it is also appropriately analyzed by the people through a collaborative environment. On top of that, the way it is being visualized is that based on the experience which we get by analyzing this data and uh, taking uh, into account that what are the ground conditions which are very specific to the Indian environment, we can go back and contribute to the RFCs as well, which are the pillars for running of the internet. So essentially, there is a contribution going back to improving the internet overall, not only for the country, but overall for the improvement of internet itself. And then at the last point, which I would like to say, that the way this measurements helps is to give insights to the regulators and people who are taking decisions to come up with the appropriate public policies which will make our life as a citizen easier. So if this data continuously indicates that latency of a particular region never drops below 300 ms, then definitely we can share this information with the regulators of that particular geography and say that there is an urgent need for an internet exchange point at that location, or there is a requirement of a data center at that location. So those kind of public policy decisions can also be influenced through this measurement. But what is required before all those things happen is that a national backhaul of people who are using this platform. And the entire purpose of doing this AIORI 3 and faculty development program and reaching out to you guys and trying to do the workshop is to make you all aware of an existence of such a platform and an opportunity, and also to create a national backhaul for the entire thing to happen at scale. Because unless and until things happen at scale within our country, the kind of population which we are serving, it will not make sense. So broadly, these are the 3-4 top reasons which I feel, which we started with, and we are in the journey to achieve it. And it is too early as of now, but we are somewhere there.
Thank you, Anupam ji. That's really a great initiative.
Hi, sir. This is Sharmila from SRM.
Yes.
I clearly understood your outcome. I mean, whatever you've said. 2 questions I have, sir. The first one is this Raspberry Pi, right? It's a device. Where this will be kept in our university? I'm from SRM, right? But that's the first question. Second question, as I think 1 year almost over, is there any outcome as a paper being published by your customers, or you could share over here what they have done? Anything of that sort is available, sir?
Fair enough. So point by point, first of all, this Raspberry Pi can be kept anywhere where your router is, because one end of the Raspberry Pi needs to get connected with your router. So if you have a router in your department in SRM, you can connect it there. Or if you have a network operations command center, it can go in there as well. So there is absolutely no requirement to configure it except the registration part, which Andrew mentioned. It has got DHCP enabled, so it will take the IP by itself and start working. It needs to be just connected to a router, whether in your department if you have one, or to a NOC or SOC, whatever you have in SRM. That is one.
Okay, sir.
The second part of your question, papers. The latest one which I reviewed a little while back, possibly 2-3 weeks back, is a paper from a student of IIT Guwahati, where they are trying to use the DNS data to see that what kind of standard deviation happens across the country. So since that is not yet published or it has been submitted for publication, I will not be able to share, but the past papers data will be we will be very glad to share whatever.
Yes, sir. Yeah, that would be better, so that we'll have more idea to speak to our higher authorities. This is how the research work is going on, so we can also explore more than that, like that we can convince them. That's why I asked you, sir.
Thank you. Thank you. And in the Friday session, I will request Arnav to include that slide as well, wherein
Yes.
we have the list of published papers based on the
Yes.
data which has been collected.
Right,
Yeah.
sir.
Thank you, sir. Thank you.
Thank you.
Sorry to disturb. That AIORI website already having that link, sir.
Yes,
Resources
sir.
and resources.
Portal.aiori.in.
Yeah. Thank
Good
you
evening,
so
sir.
much. Thank you so much, Bhagyashree. You are
Hello.
the TV savior. Thank you. Yes.
Sir,
Yes, Dr.
I had,
Monica.
I had two questions, sir. One is about data analysis. Is there any security threats being analyzed in this data collection part of it?
Will you be a little kind to elaborate that so that I understand?
So the internet usage is being recorded. I mean, usage trend and the thresholds which you say the latencies and all are being recorded. Along with that, is that any security threats to the country is also being analyzed, or it is just about internet usage and the part of it is analyzed in this project?
So I'll share my thoughts in two parts. One, currently it is limited to the availability and accessibility measurements. Okay. The second part is that we do have the capability as part of this network architecture which has been created to create new measurements and push it to all the 300 anchors. So tomorrow, if you have something in mind which you want to test, whether it is from security standpoint or resilience standpoint, then that measurement can also be pushed centrally from a central place to all the 300 different anchors. It can remain there for a few days or weeks. Measurements can be run and then it can be taken off. So the entire architecture has been created to not only get a fixed number of measurements, but it is elastic in nature, wherein new measurements can also be incorporated. But as of now, the answer is no, that we don't do any security related measurements apart, except from the fact that we do measure DNSSEC, which is a security at the DNS layer. We do have the capacity to measure BGP sec, which is again at the network layer. But if you are thinking from the application layer standpoint, we don't do that.
Okay, great. So, and one more question, sir. And is it only about the internet usage measurement, that is about the traffic and so on? Or is there any particular project which has been given to the users and you try to analyze how the network is behaving for such projects?
So that can be done. That is exactly what we will showcase in that session 2, that how
Okay.
it can be used in that fashion. Uh, so while for today's session, we have explained that it is how it is measured and from accessibility and availability, how it can be measured as part of an overall project and how the measurements which gets collected can give you an overall perspective. Those are the things which we will share it in the next session. But
All right.
whenever you say that you want an information at a network level, so I'm assuming, say, you have in mind that your college network or an enterprise network, then mind that there needs to be few anchors installed inside your network. Only then you will have a much more detailed output to give some kind of recommendations for improvement of the same. But from outside in perspective, it will give you an indicative report, but it will not be something which you can act very swiftly. So, because that is, again, the data comes at a very macro level. But if you want network specific improvement, if you want, say, for example, we have learned from many of our colleagues, faculties, that the one of the biggest challenge which the institutes face is a lack of bandwidth during the daytime when there are so many students and faculties there. Also, there are challenges when there is an assignment which is being given and everybody is trying to upload at the same time.
Yes.
So for those challenges, to do that kind of analysis, you will have to install a couple of anchors inside your network, and then you will be able to pinpoint that what needs to be done.
Okay. Very nice, sir. Thank you so much.
Sir, good evening, sir.
Good evening.
Sir, you talked about anchor points in each location, right? So you told IISc you have anchor, IIT Guwahati, like that. You are going to analyze a particular organization, right? It is not in the overall that location. We can't get that means you have to have anchor point and each and every organization, isn't it?
No. So first of all, ma'am, I would like to clarify that IIT Guwahati and Sri University and others are not the anchor points. They are our hubs. Okay.
Nodes, we
So,
call.
so nodes, what we call it. So these are the places which you can say that it is like a junction. Okay. In where
Okay.
it is a little larger in nature. It doesn't by itself doesn't do measurement, but it helps the measurement process overall. And it is designed on a CDN basis. So on the CDN architecture, and it currently we have got it at around 10 places across India. Anchors are much smaller and much flexible, much agile devices, which in the form of a Raspberry Pi, which gets pre-configured at our end with the AIORI code, and then it gets deployed at different locations. So those devices act as a normal user like you and me sitting in an open internet. So the entire idea is to get the insights on internet working, its behavior and usage, and uh, how it is working on the ground like a normal user. So those devices act like as if you and me are running a ping command or a trace route and all. So that's what the thought process is of
Okay, that means
creating an anchor.
anchor means it will connect with that node, isn't it? You
It
told
will,
10 node.
no. It will not connect with a particular node. It connects with the central node, and then the central node is mirrored at 10 different places. You will have to think like that. So it is not that an anchor in Guwahati gets connected to IIT Guwahati. It is not like that. So the anchor at IIT Guwahati gets connected to an AIORI central command. And then the central command is not a central command, but it is distributed in nature. So you'll have to think like that.
Good evening, sir. Can we understand it as like we are connected to a star network? The
That's correct.
central node is AIURI and other are the nodes independent, basically, just facilitating the measurement.
They're not only facilitating measurements, they are also storing the data. Okay. They are ensuring that for getting the results of measurements, you necessarily don't need to travel every time to the central command, which is at Calcutta. Okay. So the entire thing is replicated at all these nodes so that the workload is distributed.
Okay. And
So
one more
it
thing.
is exactly the way. Do you watch Netflix?
Yes, I
Yes.
do.
So the reason why Netflix works efficiently is because it has the same movie content replicated at 10 different places. Okay.
Okay,
So
got it. From where the bandwidth is better, they are delivering the content on that particular node.
Absolutely, ma'am.
Correct. One more thing I was wondering that you people has provided us with the certain registration link to your website. I have done that, but I'm just able to see the notes as you are presenting here. Uh, I was wondering, without creating the cluster, we are not able to monitor anything. Is it the case? And if it's so, then what is the procedure to get it registered on your network so that we can monitor our bandwidth also?
No, so if you want to monitor your bandwidth, I think that is a different question, ma'am. Okay. Monitoring your bandwidth, I really don't understand. I don't think
It's
we have
about
the
this is about the AI, the network uses of basically AIORI, or I'm just losing some context.
No,
I think.
okay. I'll explain. So the entire purpose of this measurement is to see how the internet is behaving overall and at a particular location, from a particular location. Okay. So say for example, how Amazon.com or your institute's website is operating at what latency, say in Kerala. So if you tomorrow you want to see that you want to have that this input that how your website is opening from Kerala, whether the users are able, the students are able to open it seamlessly, whether the parents are able to access it naturally. You don't have an option currently to go to have to the only option which you
I
have is
got
to ask someone in Kerala to do it. Okay.
I got
Now,
that point.
this
Basically,
is
how the internet is behaving on my particular
correct.
website, I can analyze that and find out the latency over there
Right,
without
right.
going actually there. I got it.
Absolutely, ma'am. Absolutely.
Good, thank you.
Any other questions, comments?
Sir, good evening. Sir, good evening, sir.
Good evening.
Hello. Sir,
Yes, please.
sir, good evening. Sir, my name is Bharat, sir. I am from Potential Engineering College, Vijayawada, Andhra Pradesh. Uh, Sir, recently we are working on a project for web cameras. So I latestly came to know there are STQC norms which is introduced by our government, because those norms are related to internet connectivity and how the secure layers are being monitored. So most of the internet now CCTV companies are abide to follow that STQC norms. So may get the data from AIORI in that regard, sir. I mean, regarding the security of the CCTV infrastructure, all these things.
Are you referring to the STQC norms for
CCTV cameras, yes, sir.
CCTV cameras? Yeah. So
IP based, especially IP based cameras, where now every camera is being connected to the internet protocols. Regarding that, sir, is there any enlightenment of data that I can get and flow that to my students, so that it will be helpful for their project and everything?
no, it is absolutely possible to use it for that purpose. I'll request my team to provide some details into the next session, how it can be done.
Thank you, sir.
That's a very good use case which you have highlighted. We have not thought about it, but we will look into it and we will provide in how it can be done in the next session.
Thank you so much, sir. Thank you.
Sir,
Yeah,
can I have
please.
one more? Sir, this is regarding the category of the users, sir. We have a faculty and a student category. So, what's the difference in this login categories? Like what they have the access to and what we have? Is it both same, sir, or different?
No, so faculty and students are their roles are same and different at the same time. Okay. So if the faculty is also doing a research and student is also doing a research and both of them are firing measurements to understand something, the roles are absolutely fine. But the reason why so there was no need actually to differentiate between faculty and students. But then we received comments from learned faculties over last couple of years that we want a system where we can assign some tasks to the students and we want to monitor those tasks as well. So say for example, if you want to assign a task to a student to measure the ping for 5 different websites, that is you can do if you are having the faculty access. So 5 students can attach to yourself and you can delegate some task. They will run the measurements. It will be available in the portal, and you will be able to see that they have actually performed the task and have not used ChatGPT to give you the answers.
You can also download the results in various formats, and with that, you can use that for your research purpose.
Okay.
Thanks, Andrew. Any other questions or comments?
I
Yes,
will
sir,
go
one
through
more.
it in session 2, the whole overall portal, how student will access and how faculty
Okay.
can with all the
So,
features.
so there are a couple of questions in the chat which I will quickly answer. The first one is there any charge for anchors to be installed? No, there is no charge. We do give away anchors. It costs us nearly 10,000 rupees. We do give it to the interested faculty members to deploy at their institutes, and um, but you will have to bear the cost of the whatever small amount of electricity which is consumed, and you will have to give the bandwidth to the tanker. So that is my response to that question from Saket. The other question is from Dr. VG Prasuna. What is the roadmap for AIORI over the next 2-3 years? Fantastic question. The first roadmap for the first target. So this project started in 2019, and the bulk period of our COVID went through developing of this platform. Okay, so we had something working on a mission mode during the COVID. We completed the development.
हेलो
Yes.
सर, मैं साकिब बोल रहा हूँ. आई एम स्पीकिंग साकिब फ्रॉम राय यूनिवर्सिटी. तो मतलब 10,000 रुपये आई हैव टू पे और यूनिवर्सिटी हैव टू पे?
No. I am saying that this is what we give to the interested faculties. You don't
Faculties.
need to pay. Yeah.
Okay.
Hi, this is Panchami. Hello.
Yeah. Panchami, just let me complete the answer to Dr. VG Prasanna, and then I'll
Okay,
bring
okay,
you.
fine. Yeah, thank you. Yeah.
Yeah. So in terms of AI, roadmap for AIORI 3 over next 2-3 years is to create an indigenous sufficient amount of anchors within the country so that we can get a high level data from at least from each of the districts at district level. Then we also want to have a community of people working on this, because measurement will, me and Anand and Arnav and Andrew will not be able to do all the research related to internet measurements. Okay, so the roadmap includes creation of a very active community of researchers on this longitudinal data which is there. And because this data is something which you have fired by yourself, and it is a data which is absolutely raw and never happened before, this is a very good option to publish your research. So we want to make this data publicly available for any other researcher to take it forward. And then the third objective is to in our roadmap is to start contributing to the international standardization process on internet, which is happening at IETF. So this is where I will sum it up. Thanks for your question, Dr. Prasuna. Excellent question. Now, Panchami, you can ask your question.
Hi, I'm Panchami, and I'm from Indian Institute of Information Technology, Kottayam, Kerala. I would like to speak about this, ask about this anchor. Where is there any agent deployed, and if it's so, what about any privacy policies involved? So yeah, that's it. And moreover, I want to know about the post-quantum contribution in the so in the slide, I came to know that some contributions were there. So actually, we are a group of researchers who look ahead for those kinds of contribution as well.
Wow. So too many questions. What was the
Yeah.
first?
Sorry, the first question is that we have to install our anchors in the institute premise, right? So if it's so, obviously there should be some agents deployed so that the internet should be monitored. So is there any privacy policy involved in that?
Yes. So Definitely there is a privacy policy which is available on our website, okay, which goes along with it. The entire reason for deploying it at an institution level was that though this anchors work on an active basis, which means that it gets into an action whenever you give it a command. Okay, so it is not collecting data on a passive basis wherein the entire traffic is being looked into and then we are trying to analyze it. That is not the
Yeah.
purpose of
Yeah,
this.
that and because it's a pie, right? Because it
Uh,
has its own limitation and
right,
it's a resource constrained one. Yeah,
right,
that we do understand.
right.
And yeah, so that I will look into the privacy policy. One another query is that is it one device alone can tackle the internet capacity or the latency over the internet? Because it could be a part of a LAN or some sort of network. It's not the part of an upper structure, right? In our own institute or anywhere we deploy. So is it a single device alone will satisfy to get into the correct picture to get a how the whole institute internet works? So is it feasible with
Look, what we have done, we have taken cue from how the measurement systems are deployed across the globe. Okay, so if you look at Europe, a similar measurement systems possibly has somewhere around 25 to 30,000 no anchors which are there across Europe. Okay, so with that many anchors, it is fairly possible to understand at a very high level what are the issues with respect to internet across Europe. Okay. So from Indian standpoint, if we are able to deploy somewhere around 5,000 to 10,000 anchors, I think we will be at a very fairly good position to understand at a macro level how things are working. So currently we are at 300. We have a long way to go, but that is part of our roadmap.
Yeah, I understand. The last question is that, like in this presentation mentioned about the post-quantum migration towards the post-quantum. So is there any way so that we can collaborate the work because we are the researchers who are working in that particular area, especially in the TLS and in TLS?
No, so we do have a separate group which is working on post quantum.
Okay.
Here we are working with a prof from ISI.
Okay.
He is an advisor to this entire program which we are running on post quantum.
Okay.
So if you want to contribute there, we will include you in our WhatsApp group, which is deliberating and working on it. So it's a
Yeah,
very
so
informal group, but
oh,
we do share our findings and we work together on that. So
oh,
we,
great.
we
Yeah,
will be
we
happy to
have
include you there.
yeah, we have few good research publication in IEEE transactions in this post quantum area. So we really would like to contribute because the actual we are actually researchers and we want to like scale up our research or the result in a more application way. So we have the open SSL and we are working on that, but we actually looking ahead in this regarding this opportunity. Yeah.
Fair enough. Fair
Yeah.
enough.
Yeah.
Actually,
Yeah.
we do have your contact information. So because you have registered in our portal, so we will
Oh,
include you in that post quantum
oh,
group.
that's
I've also noted, Srijit, please note that, and also please note that Dr. Prasuna has also expressed the desire to be included in the PQC group. So we will do that. Uh, um, to answer to the question,
yeah.
we
Thank you so much for addressing the queries. Yeah.
Yeah,
we
sir.
will need to
Again, this
have.
is Sharmila.
Yes, Sharmila, just give me a
Yeah.
moment. Let me complete
Yes.
the questions from Dev Krishna Das. I think Sijit has responded to that. So there is not, that is absolutely fine. If you are facing any problem, Mr. Das, Dev Krishna Das, then my team will definitely help you on that. There was a question on how long is the data retained. So we plan to retain it we want to make it as a publicly available resource. So the initial target is possibly mm, nothing limiting us, but we are trying to find out that how efficiently we can keep that data publicly available. So possibly what we will do is, as the data volume grows, we will find ways to keep just the macro part of it and not the whole data set. But we don't want to throw away the measurement data after, say, 5 years or 7 years, nothing like that. Yes, you
Yes,
can
sir.
ask the next.
Yes, sir. This is again Sharmila. Sir, I just have one more question. This anchor is there in Raspberry 5. Suppose we are connecting it to a local router in our department. And then if not, we have to connect to a network center. But the latency will be differing in both the cases, sir.
Yes.
See, if we are running google.com.
Yes.
So you have done, so it is better you suggest that we have to connect to network center, or what is your suggestion, sir?
No, because the user is outside. No, not every user is connected to the network center. So network center will give you a very good data, which possibly is not the reality on the ground. So we always suggest that anchor should be very near to the user so that it replicates what a normal user is facing on day-to-day basis.
The better to be in department then, right?
Right, absolutely.
Yeah. Thank you, sir. Thank you.
Sir, do we need to sign a letter of intent or agreement, something like that? Like, because how do we take it forward to the official, to the our network center officials?
Yes, so there
Get
is a
approval.
two, 3-pager MOU document which is there. We can share it with you. You can get it signed, and then we will ship you the Raspberry Pi.
And the installation, you will guide us how to install it.
Yes, ma'am. It is pretty simple. You are learned enough to do it by yourself, but
Okay,
my
fine.
team will be there to take you through that.
Okay then. So minimum you will give 10, sir. Like how it is, like 1 or 10, like from your end.
1?
How many Raspberry Pi you will give, sir, for us? For this?
One per institute. Yes.
1 per institute. Okay. So 1 per institute, if it is in one department level, I think it will be only we can only do access for a particular department alone, sir. In that case.
Yeah, if you want more, then you understand our predicament that we want it to be distributed across India. So if you want more, then you can buy a Raspberry Pi and we can get it configured for you.
Configured for us. Okay, thanks. Thank you, sir.
Any other questions, comments?
Good evening, sir. This is Dev Krishna from Rajdhani Engineering College.
Yes.
So, sir, I was asking the workshop after this FDP that we'll be doing in our institute. It will be after or before installation of the Raspberry Pi, the anchor points.
I am really having trouble understanding your question, so if you can kindly repeat it.
Sir, am I audible or?
Yes, now very much, yes.
Okay, sir. So I was asking, sir, the workshop that we are supposed to have after this FDP in August.
Right.
Yes, sir. So we will be doing that workshop after we install the anchor points in our institute or before that?
No, anchor point is completely your choice, whether you want to install it or not. That is your choice. Okay. If you sign up that MOU form, we will ship you, you can install it. Okay. And workshop is independent of installing the anchors. That's what I can say.
Okay, sir. I understand.
You can use our deployed anchors, and then you can measure it through them actually. We
Okay,
have our deployed anchors, those are online. you can get that. You can send the request and get the response back from the anchors.
Okay, so thank you. I just wanted to know that.
Thank you. Thank you. You mentioned that AIORI is expanding the Anycast test bed for DNS by adding more academic. Could you please explain what the Anycast test bed involves? What infrastructure is required from a participating institution, and what opportunity does it provide for faculty and student research? Okay, so for expanding the Anycast testbed, you need to provide us with a server. We give you the server specifications. Generally it is a Xeon processor with 1 TB of hard disk and possibly 16 GB or 32 GB of RAM. Once you provide the server, you will have to give us the management access through to that server so that we can do the required configuration from our side remotely. And the key requirement here is when a node is being configured on Anycast basis is with respect to BGP, how BGP is configured with your ISP. So we will require some liaisoning with your ISP to do the requisite BGP. And then in terms of opportunities, the hosting institution for nodes or Anycast test beds, they can create an internet research lab around it, and they can run a full-fledged FDP program. They can have internship opportunities for the students, and they can also have some of the papers running because you will have larger data sets available with you. So at a broad level, I can say this, but we do have a document which explains in detail and which we have sent to different universities because this is the same question we keep on getting. So we do have a very beautiful document explaining that how it benefits the academic institutions and the researchers and the students. We will be glad to send it to you.
Sir, it is my request that all should visit the AIRI 1, 2 previous, all the events, those are present on website. All reports and everything is on website. So you have to visit that. So the all questions and queries can answered.
Thank you, Bhagyasri, for pointing that out. So just to let all of you know that Bhagyasri has been associated with us since AIORI 2, and she is one of our AIORI ambassadors. And we really look forward to her comments and her advice on how do we do things. And this FDP program, which you are currently part of, the AIORI ambassadors like Manu, from Christ, Bhagyasri, and others have contributed a lot to design it and bring it to all of you guys. Thank you, Bhagyasri, for all your effort.
Yes, sir. And also, if you remember that last year we are having one YouTube channel and all the videos are there. So those are also useful for these people.
Sure. So, Andrew, can you just share that information? Sorry, Andrew. Srijit, can you share that information to the whole group?
Yes, sir.
Okay, thanks. It will be done. Any more questions, comments? Hearing none, I think it is time for a lot of us to get our dinner and enjoy the rest of the day, whatever is left of the day. And we will see each one of you in our next session on session 2. And if in case you want to have more details, some more questions, please feel free to join the repeat session, which is happening on Friday. But please remember that session 2 is next week, and be there in session 2 as well. Thank you so much. So the meeting is adjourned. Thank you, everyone. Thank you, Arnab. Thank you, Andre. Thank you,
Thank you, sir.
the
Thank
entire
you,
IIFON
everyone.
Thank you,
team.
sir.
Thank you,
Thank you,
Professor
sir.
Thank you,
John
sir.
Lawrence.
Thank you.
And
Thank you.